All right, so this is the first part of our lecture on Chapter 8 in our text in industrial materials. This is, of course, covering the production of steel by casting, forging, extrusion, and powder metallurgy. We'll talk a little bit about 3D printing in this chapter as well. So, uh, it is important for you to remember the things that we've gone through in Chapter 7 on how we get raw iron ore and bring it in. So, again, you can take a look either in your chapter in your textbook or here as far as what the learning objectives are behind this chapter. So I'll just briefly kind of go through those. You can stop the video if you'd like to read over them just to make sure that you understand. So here is where we're at now. Of course, last chapter was chapter 7. We talked all about iron ore and where we get it, how we dig it out of the earth, and the fact that we have 3 types of iron ore: magnetite, hematite, and taconite. We mentioned that taconite, or the less desirable of all of the different iron ores, is the only form that we still have available, and that it is not that much actual raw iron in it. I don't remember, I think it was 18 to 30% of taconite iron ore has iron, so we got a lot of gangue. That is the waste materials there too, so that we do have to basically break that down through the process of beneficiation, which is more or less breaking all of that material up and getting it crumbled so that we can extract through magnetic properties the iron that's in the taconite. And we mentioned here in the U.S., we've pretty much largely exhausted our supply of magnetite and hematite back before 1960. So, which is kind of one of the things that has led to us trying to find and develop other types of materials as well. Now, again, in Chapter 7, we were talking about how it was reduced and getting refined into that liquid steel. Then we also mentioned about how most of our actual steel nowadays is coming from scrap material. And that's largely been recycled, so that we're using both, but most of it is scrap nowadays that we're putting into making new steel for our processes and our procedures that we need to use in industry. So we mentioned about the integrated mills, how they have all functions of steel. We talked about the blast furnace, basically at this stage turning it into pig iron, that we use the pig iron in the steel. Then we go into the basic oxygen furnace or direct reduced iron. Most of the recycled steel is being done through a direct reduced iron furnace, or DRI furnace here. We mentioned about the nomenclature and the naming system for different types of alloys. So if you're not familiar, make sure that you again understand the SAE and UNS system. And then we talked about the actual manufacturing process at the mills of how they use hot line rolling to produce the semi-finished goods of plate, sheet, strip, and bar, and how it's important there for those line rolling and how it changes the microstructure and the performance of the steel here. So now we're going to continue on into Chapter 8 with, notice we don't get into plate, sheet, or strip bars. So that is, of course, the semi-finished goods here at this stage where we're at the ingots and slabs and blooms. Now we're going to go into Chapter 8 where we're going to talk about casting, shapes, forgings, extrusions, and some of the other processes to make. So that's make steel, and that's what Chapter 8 is all about here. All right, so when we talk about castings and the production of castings, it is very important to understand that castings give us a much more desired shape that we can't always fabricate from plate or flat sheet stock. Now, oftentimes, even if we could take and fabricate that out of plate, it would be a lot more expensive because of the amount of machining processes that would have to go on. So typically, the use of castings is a way to get more complex shapes out of that steel and basically have less processing time for secondary and tertiary type processes that would need to be done in order to get a part to its final shape and dimensional size. In order to cast these parts, it does require a mold to pour the liquid metal into. So, of course, that mold has to be able to withstand the higher temperatures of steel. So that leaves us with other types of materials. A lot of times that's we're talking about sands or ceramics, glasses, other types of materials that would absorb and be able to handle the higher heat as we pour that liquid metal into the actual mold. The mold itself is going to hold and have the desired shape. So as the metal solidifies, then that's going and hardens. That's going to basically make the part. So again, we are casting and melting this steel in the electric furnaces. So we do get different slag that's there to cover and use it for protection. That helps keep oxygen out and other undesirable elements that might get into the mix. Again, we want to highly control the ingredients, so to say, that's going into the actual steel itself. It's kind of like if you're baking brownies, so you would want some flour and some sugar and some cocoa powder and stuff with that, but you probably wouldn't want to put too much flour or too much sugar, and you certainly wouldn't want peanut butter added in there, unless of course you wanted to make peanut butter chocolate brownies. So we have to kind of control the amount of elements and the alloys that are going into that furnace being melted down. So as we get these, they get poured into the ladle. And of course, as that goes, we can add more carbon steel. We can add different things in to make sure that it is the right chemical composition there. Deoxidizers to try to get rid of oxygen are also added at the ladle. So just before the molten steel is poured, some of those deoxidizers are things like magnesium and aluminum. So as you take a look at this, so here, of course, you see the ladle that is basically coming off of and we've got that filled with the liquid steel. So we've mixed up other stuff into that, and of course these ladles are transported from the furnaces to where we're going to pour the casting. And the pour temperature is a very, very monitored and controlled setting. Obviously, if it's still too hot, we might change the density and the viscosity of it. If it cools off, the major concern is, of course, it cooling off too much where we won't get a pour there. So some of the things that we need to consider is the furnace melting temperature, the temperature drop while it's in the ladle and being transported, and the time in holding in that ladle where it's going from the furnace to wherever in the mill it needs to go in order to be poured. And this picture is kind of a nice picture showing the ladle and the pour process and the employees there works alongside that. So there, notice the size to scale, notice the PPE and the safety equipment that would a employee would also need to be very familiar with to make sure that they are working safely in this environment. So again, talking one of the other things that's mentioned in the textbook is the move of these ladles by forklift. Sometimes this is also highly automated through different types of chain systems or as well, but that route needs to be cleared if it's on a forklift. You want the forklift drivers to be well versed on the path that they need to take, and you don't want any obstacles in the way that's going to either slow them up as they try to get there, or that's going to cause them to have to hit the brakes and stop, that might kind of jostle that and get that liquid molten metal to kind of splash around. So obviously we don't want any of that molten metal falling into water. The That can be catastrophic. Water and molten metal don't really mix. You can get violent reactions, spraying that molten metal all over the workplace floor, and obviously employees can get hurt, and loss of life could result in that type of an incident. So that is something that these foundries are definitely paying attention to with their workers as well. So we talk about molds, so made out of a material with a higher melting temperature. So probably in most cases, sand is a common material that's used for this. So and it's compacted sand. So they do add moisture to it. That sand is mixed with clay, other types of materials like oils, to help pack that in around the pattern. And typically, those uh, sand molds are compressed. So patterns are pushed into the sand. So, or the sand is packed around the pattern. So, at that point, once the pattern and the sand has kind of taken on the shape of the pattern is removed, and then that allows the metal to be poured into it. Now, there are different types of patterns that kind of go into this, but the idea here too is once you have one of these sand molds, you do want to take care of it, make sure that it is being well handled so that it doesn't break or any small particles doesn't break off and mix with the metal when it's being poured into it. So talking about these sand molds themselves, there's a polymer binder that's used. Sometimes when that polymer binder is, we wait for the sand to cure. So, and then those sand pieces can be assembled to form either a 2-piece mold or a 3-piece mold, depending on the complexity of the shape. So once you've got the mold, liquid, of course, is poured. So when solidification and cooling takes place, a certain amount of time is allowed for that. Once that happens, then the sand is knocked off. So you're taking and removing the metal part. So, and then of course the sand goes back in and gets reused for another mold to be made in another mold as well. Largely your casting surfaces depends on the quality of the sand being used too. Obviously, the grain size of the sand, a real small particle sand, is going to give you a smoother, nicer surface finish. Large size pellets of sand will be more rough. Okay. Uh, I'm going to go ahead and stop the video here. We'll start part 2, going into and talking about investment casting or the lost wax casting process in the second part of this lecture.